fluid is, we call it a fluid mechanics. If a mechanic, something has to do with a solid, then it's a solid mechanics. This is deformable class that you're talking about. And if it has a or the thermal mechanics or thermal sciences, whatever, we don't usually call this way, but you know what that means. That's a thermal kit mechanics. So it has a fluid statics, fluid dynamics, solid statics and solid dynamics, thermal statics and thermodynamics. Now, fluid can be static and dynamics, right? And if the water is contained and it doesn't move that much, then you can treat that as a static. But usually, it moves around, right? We don't call it an aerostatic. We call it an aerodynamics. So everything, right? We don't usually call it an aerostatic because the air moves around. So it's aerodynamics. That is a part of a mechanics. Solid mechanics has a statics and the dynamics. But most of them, solids are static, right? Stationary. Okay, you have a piece of beam subjected to the loads. Okay, and that thing is moving. I mean, the deforming, not moving. It's a moving, but a very, small amount. That's the other, usually the solid mechanics are statics. But that doesn't mean solid mechanics, we don't have a dynamics. Yes, we do. That's a solid, in this case, we call it a structural dynamics. Okay, studying the vibrations of the buildings. Okay, yeah, vibrations. That's a structural dynamics. Thermal mechanics is a statics and dynamics. But however, can you be able to hold the temperature at one place? Generally not. Temperature flows. That's why you have thermodynamics. We don't talk about the thermostatics. So these are all mechanics right here. If you understand the fundamentals of statics and dynamics, and this will cover pretty much everything right there, the entire 4 + 5 years of mechanical engineering disciplines. And why are you taking dynamics right now? At the end of, about to graduate. These are supposed to be maybe second semester of your, what do you call those, sophomore year. Most of them doesn't take that. They took it at the very end. Now you see the entire picture of the, entire subject matter. What is the difference between the fluid mechanics and solid mechanics and thermal science? Nothing much. The governing conditions are different, that's all. That's why I was more of an aerodynamicist before I became a more solid mechanist. Okay. Only difference between this guy is if I take out the all the acceleration term, then it's all become a stationary. Okay, it took about 10 years to understand the concept, unfortunately, because no one really told me all this. Okay, throughout the my college careers. So I'm telling you, look at the entire picture of where you stand and what these subjects are all about. All right, so much for that. Now you know what the statics and dynamics and mechanics is all about. Okay. Now today we're gonna let me see. Today we're gonna go over the chapter 11. What's the title of it? Let's see. Kinematics of particle. And I think 12 is probably talking about the maybe kinetics of particle. 13 might be the energy related. Okay. I'm not sure. I'm just guessing it. Okay. And chapter 14 or 15, 16, 17, I think this is some special cases. Talks about the kinematics of a rigid body, kinetics of rigid body, and the energy method for a rigid body. So that's how it works. And then maybe 18 or 19 is talking about the introduction to the vibration analysis. And, okay. So that's the entire mechanics. I mean, the dynamic class that we are going to look at it here. Then what is the kinematics and what is the kinetics? We know what the energy is, right? What is a kinematics and what is a kinetics? Whenever you have a something, somebody asks you to find the, hey, what is the position and the velocity and the acceleration at certain time, then that's the kinetics. So this describes the where is this particular particle with the velocity and acceleration at certain time. You're driving from Long Beach to San Diego, okay? Mostly you're going to be speeding up, right? Your highway speed is limit is 65, but who drives at 65? And sometimes you drive at the 70 or 75, all slows down to 55, or you can go back up to 80 and 90. So start the clock in here. You're driving down, and I'm going to ask you and call you out, hey, 10 minutes passed, where are you? Oh, I'm passing by the Irvine. And how fast are you going? Oh, traffic is not there. So I'm speeding up to about 80 miles per hour. And what's your acceleration? Well, so and so. And then I'm going to call you again in an hour. Where are you? I'm at the ocean side. Okay, what's your speed? Guess what? It's a bumper to bumper. It's a 30 miles per hour. Okay. So whenever somebody asks you to do the position and velocity and acceleration at certain time, that's a kinetics. That's a study of an object. Position. Where are you? How fast you're going? Velocity. What is your acceleration? That's what it is. Then what's a kinetic? Well, kinetic is a study of the relationship between the force and the accelerations. That's it. Particle and the rigid body. Only difference is what? If we have a one particle with the forces and accelerations, and we measure the positions and velocities, while this is moving in somewhere, that's what that is. But what is a rigid body? If you have a multiple, the particles, it becomes a rigid body. Okay. So there isn't much difference between this to this. So if you nail this here, this would be a lot easier. Don't wait until here in order to capture this. Trying to understand the concept of this, then you're out. That's why I'm asking you to study constantly. That's probably the key. More time that you put it in, more efforts that you put it in, better the grades. Haven't you heard that the what you get, what you pay for, right? I mean, that doesn't mean that there are some bad apples, at a high priced, But anyway, generally that's what the thing is. Don't expect that I wanted to get an A, but you only put about an very minimal, and it's not going to happen. Okay, but I'm talking about in general sense. Okay, people are different. You and I are different. You two, you next to each other is different. Okay, even wife and what is it? The husbands are different. Brothers and sisters are different. Okay, so the way how he perceives it is also be a little bit different. Okay, maybe what is it? Many of you may like the way how I teach it. Okay, and you understand a little bit better. But some of you, boy, I just cannot understand what he's talking about. Okay, then you may have to make a decision. It might be better to go take the other professors. Okay, all right, and may have some good chemistries. So my job here is to get you trying to understand the fundamentals of the principles and underlying principles in dynamics. Okay? And I'm telling you, if you lost here and here, you are very lost. Okay. And this is not an easy subject matter. Okay. So I suggest that you gotta feature wet and start doing, and that's what I'm kind of asking you to do that, right? Maybe I'm carry out the maybe I carried out too much here. Anyway, I'm not your father or I'm not your mother, but as a professor, I feel a little bit of responsibility in that sense. If I'm not caring about you, I probably won't say anything like this. Okay, but if somebody was a little bit offended by what I said, I offer my sincere apology, but what I want to say. Okay, let's go take a look at what's going on in here. Here is the position x, and it can be written as a function of t, time. The velocity can be written as a position variations with respect to time. So first derivative of a position with respect to time would be your velocity. Acceleration is a variation, velocity variations with respect to time. However, since v, the velocity is dx dt, and the second derivative of a position is with respect to time can be also your accelerations at that time. Okay, so these are the relationship between the position, velocity, and accelerations. Now, there are a couple of special motions. The first one is a motion of the object with a constant. velocity. Okay. I think your textbook called that as a uniform rectilinear motion. Okay. That means the object or particle in this case is moving with a constant velocity. So your velocity is defined to be a constant, some number, 55 miles per hour, constant, 20 meter per second, constant. I forgot the light of speed, whatever, miles per seconds. We'll just go and chip through it. That velocity is kept constant. So a particle is moving at a constant velocity, then what is my accelerations and what is my position? So acceleration is easy, where I will just take the dv dt. In this case, v is a constant. So whenever you have a variation of the constant, and that's going to be equal to 0. So uniform rectilinear motion, the velocity is constant, but acceleration is 0. Okay. But what about the position? Okay. Now the velocity is defined to be dx dt. Oops, I went too far. And this guy is v naught. So I'm going to go ahead and do this way and integrate at the position 1 and 2. And this is going to be x2 minus x1 equal to VOT in 1 and 2. Okay, but it doesn't really matter. One equal to VOT2 minus T1. Okay, now x2, and I'm going to add and subtract the x1 left and right hand side, or otherwise I will just go ahead and push that over to the other side. X1 plus V naught T squared minus T1. Now if I select T1 is equal to 0, okay, I'm going to make that as a reference, and the x1 is x naught, then it will say my position vector would be x naught plus v naught t here. Okay, so my position would be, for uniform rectilinear motion in this case, would be the initial position. If this could be a 0, then that's going to be a 0. Okay, this is where you measure from. V naught, the velocity, okay, constant velocity that is given, and time. Okay, so that's what it is. Now the second special case is uniformly accelerated rectilinear motion. So what that means is your acceleration is constant. moving in a straight line, motion dynamics. So xt, we are interested to find the position and velocity and acceleration. Acceleration is a constant in this case. But the other motion, the uniform rectilinear motion, the velocity was constant, but in this case, its acceleration is constant. So we wanted to find the position and the velocity of this type of motions. So A, the acceleration is defined to be dv dt, and that is a constant. So this number is any number, 9.8 meter per second square. 386.2 or 4, inch per second square. Something like that. Okay. So I'm going to solve this guy by doing this. And again, I'm going to take the integrations. And this is going to be a v equal to v naught plus a naught t. Okay. So my velocity here is v naught plus a naught t here. Okay. So this is given. That's a constant. And that is the initial velocities. Oh. Okay. Now we know what the velocity is. Now we can be able to find the position. Yes. So the position is, once again, uh, is the one that we need to find. But look at the velocity. The definition of the velocity is first derivative of x with respect to time, which is v naught plus a naught t. Again, dx v naught plus a naught t dt. So I'm going to go ahead and take the integration between, whatever the case. If you wanted to do it, well, that would be okay. So I'm going to just go ahead and do this. It's going to be x is equal to x naught plus v naught t plus 1/2 times a naught t. So that is your accelerations. So in these two particular, very special case is defined. I mean, we define the position, velocity, acceleration at any time t. But again, this is initial position. This would be initial velocity, and that is the constant or uniform accelerations. Well, let's go ahead and see if we can derive from here. Once we know the position, we can derive the velocity, can we not? That would be just the dx dt. So this is a constant that's going to be equal to 0. The variable is t, so I have a v naught. Somebody didn't notice that. There is a 2 here. When you integrate this guy, okay, if you do that, then it's going to be 1/2 times a naught. This is going to be 2t. So t cancels out. It's going to be a v naught plus a naught t. Okay, and this better be equal to what we derived before. Okay, so it goes back and forth. It has to make sense. Now we know what the velocity is. We can be able to find accelerations, which is the variation of the uh, velocity with respect to time would be, this is a constant, 0. And if you, what is it, take the derivative of that guy would be a naught. So your a, acceleration is a naught. We know this is a constant value. That's where we started by definition. Uniformly accelerated rectilinear motions. Okay, so far so good? Okay. Oh, let me see. How about an example? Mm, ah, there we go. I tried to clear that thing, but it didn't go through. Hmm. Um, okay, I have a particle. And this guy moves along a straight line. That means it's a rectilinear motion. Particle in rectilinear motion, straight line motions. And somebody measured the position t to the third power minus 6 to 15t plus 40. Somebody measured that. And we wanted to find the velocity. Okay. So the velocity would be just they are taking dx dt. That's it. That's going to be 3t squared minus 12t minus 15. Okay, that's good. Now, here is the other question. I want to find out time t when velocity is equal to 0. So if this is the position of you driving from Long Beach to San Diego, assuming that it's a straight line, okay? And when I call you, uh, you know, I'm stuck somewhere in a, ocean side, and my velocity is 0. Then I'm going to look at the time, okay? Oh, so and so, after maybe, 45 minutes, your velocity at this time was 0. Okay, kind of like that. So given position, a particle, what is it, on a rectilinear motion, wanted to find the time at which velocity is equal to 0. Okay. So in this case, you just have to let this guy set that equal to 0. So this is a quadratic formulation, right? So your t, potentially you're going to have a 2 time. So that's going to be minus b, which is 12 plus minus b squared minus 4ac divided by what? 2a. So if you do that, I'm going to get the t1 equal to minus 1, t2 equal to 5, and assume that these are given as a seconds. Now, we don't have a concept of a time being minus. So we will not take this guy. We will only take the positive the time. And then, so that answers to your question. Yes, my velocity reached the 0. I virtually stopped when time was 5 seconds. Okay. So if I were to draw time and the positions, and this curve gets to be when time equal to 0, you start with the 40. So that is the initial positions. And then it came back down something like this. Okay. So 5 seconds is right there. That is the 5 seconds. And time equal to 5. So that means that you were going this way. That took about 5 seconds. And your velocity at this location was 0. Okay, right here. That's where the slope of your position was 0. So your velocity, if you drew this guy in here, then you can be able to kind of go through that. So over here, I'm not sure what that is. I think it might be a 0. You start with, you're going negative directions a lot, uh, yeah, I think the initial is minus 15 velocities, and then it's gonna be you're gonna hit that point. Let me see. So at this point, you're gonna hit the velocity 0. So you're gonna have to look at the what is it? The slope variations. Okay. So it's reaching something like this, and I imagine that it's gonna be something like that. Okay. Anyway, so see if you can verify that the graph of this guy follows that through, or it could be the something like this. Okay. So minus positive, and then it's going to be changing it anyway. So so that's how you take a look at those. Okay. Now, one guy, and another question would be, find the position and distance traveled by the particle at that time. Okay. So what is the distance traveled from here to here? So it took about 5 seconds to get there. Then all you have to do is put the t equal to 5 in this formulation. 5 to the third power, 6 times 5 to the second, minus 15 to 5 plus 40, and that will give you minus 60. So that means that you start with a 40 here, and that guy would be minus 50. I'm sorry, minus 60 right there. Okay, so the maximum travel distance would be 40 plus 60. So your maximum travel is 100 foot. Okay, if this is given as foot and this is given as a second. Okay. All right. So maximum travel distances and x don't confuse. The x is actually the position. Okay. Position doesn't mean the maximum travel distance is. Okay. At the time equal to 0, you are right here. At the time equal to 5, you are right here. So we are measuring your position. Where are you? Okay. So you're actually your position, you drive from here to here. So if you went 40, you went additional 60. So that's why the maximum travel is 100. It's not the 60 foot. And another thing is, why is it? I think there is a way to get it back somehow. I didn't do anything, but why is it just not giving me that? Anyway, let me do this way. And the velocity was given like this. So when v equal to 0, time elapsed was 5 seconds. Now we want to find what is the acceleration. That would be just the dv dt. That's going to be 60 minus 12. So at 5 seconds, my acceleration is 6 times 5 minus 12 will give you 18 unit per second, the length per second squared. Okay, that's how you do it. So in this curve, and this is at the minus 60, that's at the 40. So you're traveling from here to here. It takes 5 seconds. The velocity at this location is 0. Acceleration is 18 foot per second squared. Okay, so that's how you do the kinematics. Okay. Now, one guy asked another question. Asked me about what is the distance traveled by this particle from t equal to 4 seconds to 6 seconds. So that means somewhere over here, and somewhere over here. This is a 4 second. This is a 6 second. Okay. So it's going from here to here. So that means that you started out and you went to the 60 and then you come back up here. So that is the total what is it, travel distances. Okay. So we need to find out where this location is and where this location is. So the position when time t equal to 4 seconds, you can just go ahead and substitute that in here. 4, 3, 6, 4, 2, 15, 4 plus 40. And I believe this came out to be 52. So that guy is 52. Position when time equal to 6 seconds will give you minus 50. So that means, let me put it this way. I think my my guess was not correct. So this, okay, good.
Professor,
yes.
sorry to barge in, but we just got canceled for the D1DA. If people email the D1DA email, you will be able to opt out of the digital access.
Oh, okay. Well, thank you very much for informing that. All right. So you just have to go through that process and clear out whatever. Okay. If you need to purchase the ebooks, please do so. If you don't, then go to library and pick up any dynamic books and start, looking at it. Generally, the sequence of the chapters and whatnot is the same, but I would prefer you to have the 12th edition of the textbook that I have, so that whenever we kind of communicate, problem so and so, then we will be in alignment. Okay, and when I was your age, we used the same book, but the things has been changed. I mean, I may have, I don't know, maybe very early version, maybe second or third editions. Now it's up to the 12th editions. But the similar and the same scope of the context is still there. It's a really good book to have it. Anyway, thank you for the but you haven't, looks like you haven't looking into my lecture during this time. Anyway, so this is what happened. And in fact, at the 4 second, wait a minute, why is it going? At the 4 second, and the position was minus 52. 6 second, I think it actually went to over here as a 50. Okay, so we know what the 60 is. So from 4 second to 5 second, okay, we traveled how much? 8 foot. And then 5 to 6 second, and it traveled minus 60 to a minus 50, the position. That's the positions. So difference between the 50 and 60 is 10. So the travel distance is 18 foot between 4 to a 6 second. So what this person was, he was going down here and stop it and have it change its directions. Okay. So in this case, the velocity is 0. Actually, he stopped it and changed the directions. But that doesn't mean the acceleration is 0. So don't forget the velocity. I mean, it doesn't. I mean, the acceleration can have some number even though velocity is 0. Okay, Don't think that the velocity is 0 and acceleration 0. No, that's not true. Okay. Okay, okay. Let me see what the time is. Ooh. All right, let me clear the. Wow, interesting. Why this is not clear? Very interesting. Things has been changed. I haven't touched this Zoom thing, since the last semester, and a lot of things has been upgraded. I may have to adjust it to that. Anyway, oh gee, I'm not sure whether this is necessarily a better things. How about another example? I have some kind of ball, okay, and this would be at I'm holding it, and this is at the initially at rest, and I released it, and it's going to travel downward. And when this guy travels in this direction, 11.28 meter much, okay, I want to know what is the position, what is the velocity, and what is the acceleration, and how long does it gonna take. So in the initially at rest means, okay, and I also have a position here, which is x naught, and the velocity at this guy would be v naught, but because of the initially at rest means that it's not moving anywhere. Okay, so that's it. Now, if I drop it, it's gonna what is it? It's gonna go through the this particle in motion. That would be straight line. That would be rectilinear motion. Okay, and if I were to put my coordinate x direction in this direction is a positive. So downward is a positive. And if I drop this guy on the earth, okay, and the gravity of the earth is pulling it, so the acceleration in this case is a constant, 9.8 meter per second square. Okay. So, and whether here or here, the Earth is pulling this particle at the same rate. So, acceleration is, oh my God. I'm not sure why this happens. Okay, can you see my monitor, right?
Yes. Yeah,
okay. Yeah, thank you for the verification. Maybe I'll use the different one. Okay, so initially, this ball is at rest. Okay, it will have a position, velocity, and acceleration. We know this is going to be a gravity. And when this guy travels 11.28 meters, I wanted to find what is the position, what is the velocity, what is the acceleration, and time it takes. Now I'm going to give a reference time. I'm going to measure the time from position 1 and 2. Okay, I'm going to start with a 0. Okay. Now I'm going to measure my position from the position 1 and give the downward x direction as a positive. So in this case, my initial, what is it? The distance or the position set that equal to 0. So this and this makes things a lot, easier. And the velocity, initial velocity, since because of this is at rest initially, the initial velocity is 0. Okay. Now the motion that governs 1 and 2, this is rectilinear motion with a constant accelerations. So therefore, your what is it? The kinematics governing this motion is this, right? Remember, x of t is equal to x naught plus v naught t plus 1/2 times a t squared, right? And then the velocity of that guy is v naught plus a naught t. Acceleration is constant a naught, in this case the gravity 9.8 meter per second. Notice that I didn't use the minus. That's because I defined the x to be the downward. If I define the x to upward, then the acceleration should be minus. Okay, so this is the governing equation for this particle in motion. Okay, so and these are the kinematic stuff that we need to find. Okay, so how do we do it? First of all, we know the position. This was given. Find the what is it? A kinematics when the ball goes from 1 to 2. That distance is 11.28. So position 2 is a 11.28 meters from the position 1. So that's a given. So we just have to find the velocity, acceleration, and the time. Now, if we know how long it takes that this guy's travel between position 1 and 2, then all we have to do is substitute that in here to find the velocity and the acceleration. Acceleration doesn't change. So that's given or we know. Okay, so we have to know what the velocity is. Okay, so you go looking into your governing equation. If I give these two known parameters, okay, and I wanted to find the time, and go take a look at it. I mean, which equation? Will give you that. So if you take the acceleration, then it's not going to give you any time because right. The velocity information, yeah, that is true, but I need to know the velocity as well as time, so that equation we cannot use. But when you look at the first equation, so we know what all the x position information We know the initial velocity, we know the accelerations, and there is only one equation with the one unknown, which is the time. So I'm going to choose that. So xt is equal to x naught plus v naught t plus 1/2 times a naught t squared. The x naught is 0. Cool. V naught is 0. Cool. Plus 1/2 times a naught is 9.8. T we do not know. What is the position at the 2 when time t? So 11.28. So find the time when the ball hits or pass through the 11.28. So your t in this case would be plus minus 1.517. Take the positive 1.517 seconds. So it will take 1.517 seconds. Now with this, you go ahead and substitute that in here. Now this guy is 0, and this guy is 9.8 times the t, which is 1.517. Then your velocity is 14.869 meter per second. Okay, that's how you do it. Okay. And I really wanted to go through the second example, but I'm going to give you that as a kind of a homework problem. And your homework is this. This is going to be your the x directions. And the initial velocity over here would be v naught equal to 5 meter per second. Okay. And this distance is 10 meters. Okay. Now, I'm going to, throw this ball upward, okay, with a velocity of 5 seconds, and it will travel, go up, and then it's going to hit the, ceiling. Not, well, when I say ceiling, I mean, it's going to go up, and then it's going to come down in this directions. Okay, so this would be the initial position here, and this would be the position 1, and this would be the position 2. Okay, so with this information, I need you to find the position, velocity, acceleration, and time it takes to get up there at position 1, and I need that the same thing. Position, velocity, acceleration, and the time it takes for this guy to travel and hit that right here, 10 meter below where it tossed it upward directions. So assume this is a constant acceleration, rectilinear motions. Okay, and your job is to get the all the kinematic parameters. Okay, do you have any other questions for tonight? I think we went a little bit over. Maybe I talked too much in the beginning. Okay, if you do not have any questions, we will see you next Monday. Okay.
Sounds good.
Okay,
Thank you,
guys.
Professor.
On Monday, Mr. Professor.
Have a great